Hello students, welcome to classroom. In today's video, we will be starting a very important topic which is called refractive index. Most of the students, you find this topic to be difficult, but I assure you that if you watch this video sincerely, you will have a better understanding than your previous understanding. So that is my promise. So watch this video, and you will understand more than what you have understood so far. So it's going to be a very important topic. So let us start the lesson straight. So refractive index. What is refractive index? In simple terms, refractive index is the ratio of the speed of light between two mediums. Got it? Ratio of the speed of light between two mediums. So let us write down what is Ri. So refractive index, let me write Ri. So Ri, is equal to ratio. Ratio means division. So ratio of the speed of light between two medium is not. So speed of light in vacuum to the ratio of speed of light in medium. Let's just write medium. Now refractive index is the ratio. This division is called ratio. Ratio of speed of light in vacuum to the speed of light in medium. Speed of light in vacuum we know is 3 into 10 to the power 8. And the medium, well, we do not know which medium it is. So we cannot be certain as of now. So the speed will be denoted by V only. So this 3 to the 10 to the power 8 meter per second, this is fixed. So speed of light, it has got this symbol C by V. So the formula becomes like this, C by V. Now Ri is represented by N. So N equal to, the formula becomes C by V. Now let us take one example. Now let's say this is well, the upper one is air here. Air or vacuum, they are same. And let's say this is the second medium is water. Water. So let this be the incident ray. So let this be the incident ray. And then let this be the refracted ray. Now the incident ray is here. The medium in which the incident ray is traveling is air, and the second medium happens to be water. So the refraction is happening in the water. The ray is traveling inside the water. So remember this. Now write down one very important thing again. Very important point here, that refractive index Ri is always found for the medium into which light enters. Very important. This is the most important thing you have to remember if you want to excel in refractive index. Refractive index is always found for the medium in which light enters. Let's come back here. In which medium is light entering? Water or air? It's entering the water, is it not? It came from air and it's entering the water. So refractive index will be found for water. Alright class? Refractive index will be found for water. Refractive index is always found for the medium into which light enters. So refractive index will be found for water. So what do I write here? For this one, the refractive index formula will be N. The refractive index is found for water, so do not forget to write here W. If you write here W, that means you are indicating that we are finding the refractive index for water, which is the correct way to show. In the formula of refractive index, this is how we write. This is the general formula, but once you know the mediums, then you have to be very specific. So now here in this example, we are to find the refractive index of water, because we know the light is entering the water. So now instead of just N, you will write W also, indicating that you are finding the refractive index for water. So refractive index symbol is N and W. then ratio, so this line is here. Now here what do you write? Okay, well, we will be using this formula only. We are using this formula. In the top it will be C, okay, and then below V. What is this V? This is the speed of light in the medium, in which light is entering. So the medium into which light is entering is water, so this will be VW. Okay, so the formula for this, the RI formula for this case will be, okay, C V by W. Okay, let's do one more. Say again, so this is air, and let's say this is glass. Okay, let us find the refractive index formula for this case. So it will be, okay, so refractive index is represented by N, and what do I write here? Now refractive index, okay, which medium we are finding, for which medium, air or glass? Remember, you have to identify into which medium the light is entering. It is entering into the glass medium, so we will be finding for glass. So you write here Ng. Okay, refractive index, okay, for glass, we are finding for glass because light is entering into glass. Okay, so Ng is equal to, well, upside will be C, okay, and below velocity of light or speed of light in glass, Vg. Okay, that's how you do. Easy, isn't it? Okay, not very difficult. Now the next another important point you have to remember is that refractive index has no unit. Okay, write on this also. Ri is denoted by N. Okay, all right, so we will go to the next one. Okay, there are two types of refractive index. We will study that. Okay, that is important. That will give you more grip on this topic. Okay, I hope you wrote the notes. Okay, I hope you're writing the notes. Please write the notes. Okay, there is one or two questions, okay, on refractive index in your textbook. So if you understand this thoroughly, solving that numerical will become a piece of cake. Okay, so there are two types of refractive index. There are two types of Ri. Okay, we'll discuss them one by one. So let me draw a partition here. The first one is called the absolute. I'm supposed to write absolute. What am I writing? Absolute. So absolute Ri. Okay, let me just write absolute Ri. And the second one is relative Ri. All right. Now you need to pay extra attention now. Okay, things may get confusing, but if you understand it thoroughly, if you do not lose your attention, you will not get confused again. So do not lose your attention now. Now, what is absolute refractive index and what is relative refractive index? The first definition is the key to understanding. Okay, so I'll write the definition. So what is absolute refractive index? See, absolute refractive index is that refractive index, okay, if the first medium is air or vacuum, okay, then it is a case of absolute Ri. Very important. If the first medium is air or vacuum, then it is a case of absolute Ri. Okay, for example, all the examples that we have done so far, okay, or the example that I have shown you so far are all examples of absolute refractive index, because in all of those examples the first medium has been made air, is it not, or vacuum. Okay, so if the first medium is air or vacuum, or the medium from which light came happens to be air or vacuum, then that falls under absolute refractive index case. Okay, let me write another one. So light is entering like this, and this is air again. Okay, so the first medium is air and it's entering to water. Okay, So it's entering the water. So how do you find? This will be find like N refractive index is always found for the medium into which light is entering. So NW is equal to C by VW. So this is absolute refractive index. Okay, if the first medium is air, okay, if the first medium is always air or vacuum, then it is a case of absolute refractive index. Now let's go to relative refractive index. If the first medium is never, okay, if the first medium is never air or vacuum, but any other medium, then it is a case of relative Ri. Okay, if the first medium is never, here if the first medium is air or vacuum, in relative refractive index, if the first medium is never air or vacuum, it can be any other medium. Okay, the first medium can be any other medium. So the first medium can be say glass. Okay, the first medium is glass. Okay, the first medium is glass. Okay, if the first medium is never air or vacuum but any other medium, then this is a case of relative Ri. So this will be a case of relative Ri. Now you may be wondering, sir, what about the second medium? You did not tell us anything about the second medium. Yes, I did not tell you anything about the second medium because the second medium plays, okay, the second medium can be any medium. Okay, so there is nothing much. Okay, everything is determined by the first medium. If the first medium happens to be air, then it will be absolute. If the first medium is any other medium besides air, then that falls under relative, because there are only two cases, is not? It can be either absolute or relative. If it is relative, then not absolute. If it is absolute, then it won't be relative. So you just have to know how to shift, okay, by understanding which is which. So remember, you should be focusing on the first medium, the medium from which light is entering. So light is entering from glass, okay, and let's say this is water, okay, and so light goes like this. So light goes like this. So what happens? So the first medium is glass. Since the first medium is glass and not vacuum or air, so this is a case of relative refractive index. Now, how does the formula look for relative Ri? So again, N will be there, okay, N will be there, okay. Then refractive index is always found for the medium into which light is entering. So light is entering to water, so I'll be writing water, W. I can write W also, or I can write W also, okay. In both the cases, water is the second medium. Here's the water, here's the water, okay. Now if I write like this and I start, then this will be wrong, okay. If I write like this and proceed, then see, here also NW, okay, refractive index of water, here also refractive index of water. But we know that this is a relative refractive index, is not, and this is a absolute refractive index. So this is wrong, okay. If you write like this, this will get you wrong. So don't write like this. Here, since this is a case of relative Ri, so what you will do, you will have to mention the other medium also. So don't forget to put comma and write here glass. Okay, very important. You have to write it like this. So N water by N glass. Okay, N water by N glass. N water by N glass. N water, comma, don't forget to put comma and write the second other medium, the first medium, which is glass, equal to ratio. Now we are finding the refractive index of water, so here it will be the VW, okay, VW. Below we always write the speed of the medium of whose refractive index we are finding, okay. So we are finding for water, so VW. Here also same, okay, VW. We are finding here, we are finding the refractive index of water, so VW. Here also we are finding the refractive index of water, so VW. And upside, what will be? It will be VG, V glass. That means the speed of light in the medium glass. This is how the formula for relative Ri looks like. Okay, have a good look. Okay, things are not same, they are a little different. Okay, so you have to remember the key differences between absolute Ri and relative Ri. Okay, so with this understanding, we are ready to do some practice questions. So let us do some practice questions. It's my sincere request that you maintain notes, okay, as you watch the video. Grab a pen, pencil, a book, and practice together, because that way it'll be easier. Now, let us do some practice here. So, all you have to tell me is whether it's a case of absolute or refractive, okay? So you have to identify whether it is absolute or relative Ri. That is what you have to tell me. Okay. Now the first one. Okay. So air, say glass. Now, is it a case of absolute or relative? This is a case of absolute, is it not? Okay. Well, I have to show you the medium also, nah? So let me show the ray. So let's say this way, it's more easier for you, nah? Now, if I draw this ray, you know for sure from which medium the light is entering. Well, from which medium the ray came. So the ray came from air, okay, and it's entering the glass. So now it gets easier for you. So this is a case of, this is which case, absolute or relative? This is a case of absolute, nah? So this is absolute. Why absolute? Because the first medium is air. Okay, the one, okay, so the first medium is air. Look at the direction of the ray. The light enters from, okay, light came from this medium and is entering to this medium. This is the second medium, okay. The first medium is air, this is the second medium. Since light is entering inside glass, we find the refractive index of glass only. And since the first medium is air, this is a case of absolute Ri, okay. Next, okay, next, so this is medium X, this is medium Y. Identify which refractive index this is. Is it a case of absolute Ri or relative Ri? Which one did you pick? Did you pick relative Ri? Yes, correct. So this is a case of relative Ri. Now if there is anyone who is like, hi, how is this relative Ri? See, look at the first medium. Do you see air written here? No, is it not? It is not air here, it is X and Y. That means this can be any medium, okay? So this is not air. Okay, if it is air, it should be written air, but it is not written air. So this is a case of relative Ri. Okay, so this is a case of relative Ri. Now, next, then vacuum and then say glass. Let's just do like this. So identify the case, okay, identify which Ri it is. Okay, light came from vacuum and is entering the glass. So which Ri it is, absolute or relative? Which one did you pick? Did you pick absolute? Yes, so this is a case of absolute. Now, how absolute? See, vacuum or air is same, okay, vacuum or air is same. So if you understood that vacuum or air is same, there should be no confusion. So since vacuum and air are same, since the first medium happens to be air, this comes under the category of absolute Ri. Okay. Next, now let's write the formula. Let's write the formula for this one. So how will the formula be? The formula will be refractive index is found for the medium into which light enters. So glass, nah? So Ng is equal to, how do you write here? This is absolute refractive index, so C will be there, and V, which one? G, nah? Correct. What about this one? How do we write for this one? So this will be N. In which medium is light entering? Y. So we are finding refractive index for y. So we write here y. Then since this is relative, we have to also write x, isn't it? Then below, what do we write here? Both will be VV, but whose V will this be? This V will be for the medium for whom refractive index is found. So it will be Vy by Vx. Confusion? No, nah? There should be no confusion, okay? Got it? Then what about this one? This one will be N, it will be glass, and then since this falls under the category of absolute, it will be C by Vg. Yes or no? Okay, see, it's not difficult, okay? Once you understand, it's not difficult. Then let me give you one more example. Then let this be the normal, drawn perpendicular, na? Okay, let's say, okay, glass, and this is kerosene. Okay, then get me the formula for this case. Okay, this is glass, this is kerosene. Get me the formula. So how will the formula be? Okay, think about the formula. How will it be? Now let us work out the formula together. So from which medium, okay, light is entering? Light is entering from this medium, isn't it? Okay, light is entering from this medium. Those who were thinking that light is entering from kerosene, you are wrong. Look at the direction of arrow. Light is entering from this medium. Okay, light came from this medium and then it is entering to kerosene medium. So whose refractive index are we going to find? For kerosene, isn't it? Because light came from glass and it's entering to kerosene. So it will be NK. Okay, but wait, is this a case of absolute or relative? This is a case of relative because the first medium from which light came is glass. So this is a case of relative. Okay, those of you who came to the deduction that this is relative, you have understood. So it will be NK, G. Okay, and then here will be V, here will be V. Whose V would be right here? The velocity, the speed of the medium for whose refractive index we are finding, we right here. So it will be Vk here, and here it will be Vg. All right, this is how we do. Okay, see, light enters to y medium, refractive index is found for y medium, and below you'll be writing the velocity of y. Okay, same here. So we are finding for kerosene medium, below you'll be writing the velocity for k. Okay, kerosene. Okay, so this is it. Okay, class, it's this easy. Okay, I am sure and I pray that you have understood something by watching this video. If you have understood anything, okay, I am so thankful and grateful that it has helped you. It is my goal, okay, it is my motto and as well as my goal and my prayer that students, you learn something by watching this video. So thank you all for joining in and watching, and I'll see you again in the next video. Until then, stay blessed, take care, and God bless you all.